Alright, so this is the third part of the malware development series with Rust. In this video, we are going to develop the shellcode from C language. Two parts before this video are actually blogs, which I will link in the description below. You can check them as well. In this video, we are going to generate our own shellcode, which we can then use in a Rust language program, so that we can make the shellcode game more interesting. So for this video, we are going to follow the Hasherzade's tutorial, which I will also put in the description. You can check the PDF as well. In this PDF, the Hasherzade explains how we can generate shellcode from a C project. So we will be following that. The first thing that we need to do is that we need to check out a header file which is provided by the Hasherzade in this PDF. I will link the source code as well, so that you can just copy paste the header file for your own convenience. This header file actually provides a number of different useful functions like get module by name, and different structures are provided as well, and there is another get function by name. So these functions, this header file will be very useful to us, which I have already pasted here. I will be mostly copy pasting the codes to save the time, so that we can focus mainly on the shellcode generation process. Okay, so the first thing that we have done is that we have imported the Windows header file and the pep lookup header file, which we have defined here. The next thing that we are defining is that we need to direct the C program that the preceding code should be placed in the text segment, so that all of our shellcode is placed inside the text segment of the portable executable, so that none of our shellcode part is missing or placed in any other section of the PE. So that's why we are directing the code to place the preceding code inside the text segment. One thing that we need to note here is that here we are defining the string using the stack-based approach, which is more native to the C program, and we won't have any issues with that. And you can see that we have also put a 0 at the end to use as a null terminator to end the string as well. So the next thing we need to do is to define our main function, which we will define here. Okay, so here we have defined some libraries and function that we need to load, and we have also defined the message box window API, which we will be using for now. And then later on, first we will test our shellcode with the message box API, and then we will move to the Windows the shell execution API, which will be more useful for a shellcode. So let's first try to build up the message box based shellcode, so that we can see if it's work or not, and then we will move towards a more useful shellcode. So what we have done now is that we have first resolved the kernel32 and load library and get process address functions and modules by using the functions and by using the functions provided by the header file, the pep lookup header file. So by using those functions, we have resolved the kernel32 and load library and get process address. The next thing that we have done is that we have defined our load library and get process functions. We have defined that, and at the end we have we have created our user32. We have loaded our user32 DLL as well. The next thing that we need to do is just define the structure of the message box API, and just call that structure, so that our shellcode based EXE can be generated, and we can extract our shellcode from that EXE. So let's do that. Okay, so what we have done now is that we have defined our message box Windows API. This is the same structure which is provided by the MSDN, which you can see here, handle and the text, the caption, and type of the message box that need to be displayed. It's all that same. We have just defined that, and after that we are checking that if the message box is the handle message box API has been defined, the structure has been defined successfully, and if not, we can just return from that, so that our shellcode is not fallen into a exception or code. So we are adding checks at every point after loading any module or any function. So we are, as you can see here, we are checking if everything has been resolved successfully. Otherwise we just need to exit from our shellcode so that our shellcode, if runs, it runs perfectly. So the next thing that we need to define is to define these two variables, the text and the caption, so that we can provide these two variables to our message box API and then call that API. Okay, so we have defined our two variables, the message content and message title. Again, we are using the stack based string definition with the 0 for the null terminator for the strings, and then we are calling our message box API by providing these two variables to the API, and we are defining the type of the message box to display just OK button. So as you can see here, we are not using any external third-party header file or any third external library, so that all of our shell code is basically just present in the text segment of the EXE that we are now going to create. Okay, so first thing we need to do is we need to open the developer command prompt for Visual Studio. I'm using Visual Studio 2022. You can use previous versions as well. So once we have opened our Visual Studio, we need to once we have opened the command prompt, we need to run the following command in the console. So this is a command that we are going to run, cmd/k, and in the Visual Studio 2022 professional common 7 and tools, and then this is the bat file we are going to run. So once we have done that, we should be ready to go. Now let's navigate to the current directory where we are writing the code, so that it's easy for us to run the following commands. I'm just going to paste it so to save time. Again, we are going in the Visual Studio Professional VC Tools MSVC. Now note the version here, we are using this version, and also note the host x64 because we are generating the shell code for a 64-bit program. Later on in this video, we are going to generate shell code for a 32-bit program as well. So note the difference, and also note these three parameters as well. For now, you can just ignore them. And then we are providing the name of our C program. If you press enter, okay, we have some warning, but there is no error, and we have our .asm and .object file here. So it means that our program was compiled successfully. There was no error, so we can just ignore the warnings and proceed with the shellcode generation. So the next thing we need to do is that we need to open this ASM file and we need to make some changes. So keep in mind that we are generating the shell code for a 64-bit program, so we need to make some changes in the ASM file, and these changes will be same for whatever shell code you are generating using this approach. So you can just follow the same approach. The first thing we need to do is that we need to remove these two lines. The next thing we need to do is that we need to fix the stack alignment. Now the stack alignment won't be necessary for 32-bit shellcode, but for 64-bit if we need to perform the stack alignment, you can just simply copy paste the code. I'm going to paste now and you should be good to go. So you can just simply paste this code here immediately after the text segment. So this will perform the alignment thing for us. And next thing we need to do is we need to remove the p data and x data segment from our code. So if we could just yep, there it is. So we are just going to scroll all the way down where it says and x data here. So we can just cut it here again from the p data segment to the x data ends. and we can save it. And the last thing we need to do is there is usually a syntax error in the code which you can find here. You know what, let's just search for that. We can find for pointer space gs, and in here we need to enclose the 96 in a square brackets. So just save it, we should be good to go now. And we need to again go back to our developer command prompt, and we need to run another command. So again we are going in the same Visual Studio Professional VC, and again, but now our utility name is ml64 and we are providing it with the ASM file, and we are directing this shellcode to link to a binary, and you know, entry point, we also define our entry point. So let's just run that, and we have our EXE here. So this should be a shellcode. Let's try to run this EXE, and you can see that we have our Windows message box API running successfully. So this is a very not a very useful shellcode. So let's just try to modify our C program so that we can make something useful. So we are back in our C program. Now we can remove this message box name because we are not going to use that for now, and also we can remove this as well, this all things here. And now we are going to use the winexec API so that we can execute some commands using our shellcode. Okay, so now what we have done is that we have defined our command here, cmd.exe/c space systeminfo.exe space, and then we are going to tunnel that output into a txt file, so that ideally this should be sent to a command and control server, but we are just going to run that command. You can use any command you want, and then below we are defining the winexec API just like we did message box API, and then we are providing the command to the winexec, right? So it looks good. It should be 4 here, I think. So let's run the same commands again. We first need to generate the ASM. The ASM file is generated here. We need to again do the same stuff. Remove this and place the stack alignment here, and remove the p data and x data from the code. This should be from here. Okay, it's here, right? And then do the last thing, that replace this like this, save, and we should be ready to create our EXE, which can be done by using this command again. So our EXE is generated. Let's see. So we have our shellcode.exe here. Let's run it. As you can see, our command is executing, and if we visit the public folder, we should see a text file here, and it contains information of the system. So this is how you can generate the EXE. Now the next thing we need to do is that we need to extract the shellcode from this EXE. What we can do is that we can use the CFF Explorer. Here we can simply drop it, and we can go to the sections. Yep, this is the text section. We can click it, and you can copy it in a C++ array, C# array, whatever we want, but for the Rust we need it in the C++ array. So we are going to select that, and we can now come back here, create a new text file, let's say, and we can name it shellcode, simple, and we can place it in the text file. So this is our shellcode which we can place in any program in C++. So this is our shellcode which we can now use in our C++ program as well as in our Rust program which we have created earlier. So the next step we need to do is let's try to generate shellcode from for a 32-bit program as well. So for that we are going to modify our command a little bit. For now we are going in the 86 and CL, and now we have used, as you can see that we have used the x86 version of the cl.exe. This is a bit different because we are now generating the shellcode for 32-bit binary. So again our assembly file is generated, and we can again remove these two from this Shellcode ASM file. Now we don't need to perform the stack alignment, and if we try to find the pointer GS, we won't find that because GS is basically used in the 64-bit programs, and for 32-bit programs we need to find the pointer to FS register so that we can perform our some code fixing there. So instead of finding the pointer to GS, we need to find the pointer to FS. As you can see here, you don't need to worry about like where will I find it, because there is only one occurrence here. So we need to add two lines. Assume FS nothing, and then after that again we are going to add assume FS and error. Once we have made these changes, we can run the next command. Now we have changed again. We have changed our command a little bit. Again we are using the host x86 / now the ml.exe will be plainly named ml. It won't have any 64 with it. And the most important thing that we need to note here is that the entry point now has been changed to the main. So now when you press enter, again we have our exe here, and if you check, again our exe will be here, and it might not work here properly. Okay, it's working because I have ARM version, so it sometimes causes problem, but it's working properly, so it's fine. So now the 32-bit version is also working as well. So now again we can extract the shellcode from it, just like we did earlier. We can use the CFF Explorer, and we can drop the exe here. Now you can see that this new shellcode exe is portable 32, while the earlier was 64-bit. So now this is a 32-bit, and again we can go to the section header text file, and we can just select all and copy this to our C++ array, and then we can create a new file here, and we can shellcode 32, and we can just place the shellcode here. So now we have both 64-bit and 32-bit shellcode ready, and we can use in the Rust program that we created earlier. In the upcoming videos we are going to create shellcode using the anti-DLL, which will be position independent code. Again, it will be using the C language, but it will be much more robust because it will be directly using the anti-DLL. And in the third part, we will see how we can generate the shell code using the Rust language. So that's it for today. Let me know if it works, and if you have any questions, please let me know. I would be more than happy to answer it. Thank you.